All right, welcome back, learners. We've got another deep dive ready for you all. And this time, we're going to be looking at something that's a little bit more, well, I don't say obscure, but certainly a little bit deeper in the AWS ecosystem.
Yeah, I mean, it's definitely something that, if you're just getting started with AWS, you might not bump into right away, but
But as you start to really get your hands dirty
oh
and
yeah.
start really building out, some more complex applications, uh,
Especially if performance is a big deal.
yeah,
You're going to want to know about these concepts for sure.
we're talking EC2, instance store, and placement groups.
Right. So Instant Store, this is all about storage, but it's a very specific kind of storage in the EC2 world.
And we've got some great material here to help us break it down.
Yeah, some really good stuff.
So let's start by really clarifying what instance store is.
Yeah.
From what I'm seeing here, it's defined as ephemeral local block storage, and it's directly attached to an EC2 instance. And I think that word ephemeral, that's really important to emphasize.
It's really the key differentiator when you compare it to something like EBS, which is your typical persistent block storage in AWS.
Right, because with EBS, that data lives on. You can detach the volume, you can attach it to a different instance.
Uh-huh.
It persists even if your instance is stopped or terminated.
But with Instant Store, it's like having a super fast SSD built right into your server. It's physically part of the host machine.
So when the instance goes away, the data goes with it.
Gone.
Poof, no more data.
Vanishes. Yeah.
So that begs the question, why? Why would you intentionally use storage that's designed to just disappear?
Well, it all comes down to performance. Instant Store is crazy fast, like insanely fast. It's all about low latency and high throughput for temporary data.
Because it's right there.
Exactly. The data doesn't have to travel across a network to get to your instance.
It's like having the information on the motherboard.
It's as close as you can get. So if you're dealing with, say, temporary files or caches or anything that doesn't need to be permanently stored, Instant Store can give you a huge speed boost.
Okay, so speed is the name of the game here. But where would we actually see this kind of temporary high-speed storage being used in the real world? Like, what kind of applications would benefit from this?
Well, think about scenarios where you need, like, a really high-performance scratch pad.
The scratch pad, yeah.
So, like, cache buffers for frequently accessed data,
Right.
or if you're doing some heavy-duty data processing and you need a place to store those intermediate results.
But you don't need to keep those results forever.
Right. You just need them for that specific process.
Yeah.
Or maybe you have an application that's designed to be stateless.
Yeah.
It can regenerate its data if needed. In those cases, Instant Store can be a perfect fit.
So it sounds like you really need to understand the nature of your data and your application's needs before you even consider Instant Store.
Absolutely. You have to be mindful of its ephemeral nature. And that brings us to some of the potential downsides, or at least the things you really need to be aware of.
Yeah. I mean, it sounds a little risky, to be honest. Like, what happens if something goes wrong?
Well, the biggest thing is that if your instance is stopped or terminated, any data you had on the Instant Store is gone. Just like that.
No warning, no chance to recover it.
Nope, it's gone. So it's definitely not suitable for anything critical that you can't afford to lose. It's also not a good choice for your boot volume, by the way.
Oh, interesting. Why not?
Well, because booting from Instant Store can actually be pretty slow. It seems counterintuitive because it's so fast for everything else, but there are technical reasons for that. So stick to EBS for your boot volume.
Okay, EBS for boot volume. Noted.
And if you absolutely have to store any data on Instant Store that you can't afford to lose, you better have some rock-solid backup and recovery strategies in place.
Because if you don't,
You're in trouble.
data's gone.
Data's gone.
Yeah.
Yeah.
Now, from a more technical perspective, is Instant Store available for all EC2 instance types?
That's a great question, and the answer is no. Not all instance types offer Instant Store.
So you really got to do your homework.
You gotta check the specs. Some of the smaller, more cost-optimized instance types, they often don't have the hardware for Instant Store.
And once you've launched an instance with Instant Store, you're stuck with that configuration, right? Like, you can't change the storage capacity later on.
That's right. You gotta decide how much storage you need up front. And you also need to understand how to configure it, which involves something called block device mapping.
Block device mapping.
Yeah, it sounds a little intimidating, but it's basically just how you tell your operating system how to use that local storage.
Okay, so Instant Store, super fast, super temporary, not for everything, and requires careful planning.
Got it. Now, let's shift gears completely and talk about placement groups. This is another concept that's really important for optimizing EC2 performance.
Absolutely. This is all about how your EC2 instances are physically placed within the AWS infrastructure.
And the goal here is to be. Well, there are a couple of key goals. First, you want to minimize the risk of correlated failures. So if a piece of hardware fails, you don't want all your instances going down with it.
Right, so spread things out for resilience.
Exactly.
Yeah.
And second, you want to improve network performance between those instances. So lower latency, higher throughput, all that good stuff.
And the best part,
Creating placement groups is free.
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 I like free.
Everyone likes free.
Okay, so we've got these placement groups. And the material you've given me details 3 different strategies: cluster, partition, and spread. Let's break these down one by one.
That's good.
Let's start with cluster placement groups. What are we talking about here?
So with a cluster placement group, you're basically grouping your instances together within a single availability zone.
Okay, so they're all in the same AZ. Why would we want to do that?
Well, the main advantage is that you get the absolute highest network throughput between those instances. They're all on the same high bandwidth network segment.
So if those instances need to talk to each other a lot,
This is the way to do it.
this is the way.
Yeah, think high-performance computing, tightly coupled databases, anything where low latency and high bandwidth between instances is critical. And they can even span peered VPCs, by the way.
Peered VPCs. So like, if I have 2 different VPCs in the same region and I need them to communicate,
Exactly. A cluster placement group can help with that.
and I'm seeing a recommendation here to use instance types that support enhanced networking.
Ah, yes. Good catch. That's important. Enhanced networking gives you even more performance out of your cluster placement group.
Got it. So cluster placement groups are all about maximizing network performance within a single AZ.
That's the gist of it.
Okay, let's move on to partition placement groups. These sound a little more complex.
They are a bit more involved. So with a partition placement group, you're dividing your group into logical segments called partitions. And each partition gets its own set of racks, its own network, its own power supply.
So it's all about isolation.
Isolation is the key word here.
If something goes wrong in one partition,
It shouldn't affect the other partitions.
it's contained.
Right. So this is really useful for large-scale distributed applications. Think HDFS, HBase, Cassandra, those kinds of things.
Those big data systems that need to be super resilient.
Exactly. You can spread your instances across these partitions and minimize the impact of any hardware failures.
And you can actually choose which partition to launch your instances into.
Right.
You have that control, yes.
Yeah.
And these groups can span multiple availability zones.
Ah, so you get both isolation and high availability.
That's the idea.
But I'm seeing a limit here of 7 partitions per availability zone.
Right, that's something to keep in mind. But what's also cool about partition placement groups is that they give you visibility into which instances are in which partitions.
So you can see the topology.
Yeah, and that can be really useful for certain types of applications that need to be aware of where their data is physically located.
Okay, so partition placement groups. Fault isolation, control over placement, multi-AZ, and visibility. Got it. Finally, let's talk about spread placement groups. Spread placement groups are all about maximum isolation. The idea here is that each instance in the group is placed on completely distinct hardware.
No 2 instances share the same physical server.
Exactly. So if you have a small number of mission-critical instances that absolutely cannot go down,
This is your go-to strategy.
this is the way to go. And there are actually 2 flavors of spread placement groups: rack spread and host spread.
Okay, what's the difference?
With rack spread, each instance is placed on a different physical rack.
So like a different cabinet in the data center.
Right. And you can have up to 7 running instances per availability zone per group. And like partition placement groups, it can span multiple AZs.
So still multi-AZ.
Yep.
And then what about host spread?
Host spread is specifically for AWS outposts.
So when you're running AWS in your own data center.
That's right. And with host spread, there's no limit on the number of instances per outpost.
You get that maximum isolation at the host level. Okay, so to recap the 3 strategies. Cluster for maximum performance within a single AZ, partition for fault isolation and multi-AZ, and spread for maximum isolation at the rack or host level. That's a lot to take in.
It is a lot, but hopefully it's starting to make sense.
It is, it is. Now, are there any general rules or limitations that apply to all placement groups?
Oh, yeah, definitely. Some things to keep in mind.
Like what?
Well, first of all, you're limited to 500 placement groups per AWS account per region. And the names you give those groups, they have to be unique within your account in a region.
Okay, so naming conventions matter.
They do. And you can't merge placement groups once they're created.
No merging.
No. And an instance can only be in one placement group at a time.
That makes sense. What else?
Well, you can't launch dedicated hosts into a placement group,
Mm.
and you can't launch spot instances that are configured to stop or hibernate on interruption.
So some restrictions around dedicated hosts and spot instances.
Right.
Anything else?
Well, we talked about the network performance benefits of cluster placement groups, but it's worth noting that there are actually some specific throughput limits.
Oh, look what?
So for instances within a cluster placement group, you can get up to 10 gigabits per second for a single flow of TCP/IP traffic.
That's pretty fast.
It's really fast. But for instances that are not in a cluster, that limit is typically around 5 gigabits per second for a single flow.
So clustering really can make a big difference for certain workloads.
Absolutely.
Now, I'm also seeing a recommendation here to use the same instance type within a cluster placement group.
Ah, yes, that's a good point. It's not strictly required, but it can make things a lot easier in terms of capacity. When you're asking AWS to place a bunch of instances of the same type close together, it's easier for them to find the available resources.
Makes sense. It's like if you go to a restaurant and you say, I need a table for 10, but they all have to be in a row, it's going to be harder to accommodate you than if you're flexible. Okay, so same instance type for cluster placement groups, if possible. What about any other specific limits for partition and spread placement groups?
Well, if you're using dedicated instances with a partition placement group, you're limited to a maximum of 2 partitions.
Okay, 2 partitions for dedicated instances.
Right. And capacity reservations, they don't apply to either partition or spread placement groups.
Good to know.
Yeah. And one last thing about stopping and restarting instances within placement groups.
Oh, yeah. Remember we touched on that earlier.
So if you stop an instance and then restart it, it should stay within its placement group.
But
the restart might fail if there's not enough capacity available at that moment.
capacity can be a tricky thing.
It can, but there's a little trick you can try if that happens. If you stop and restart all the instances in the placement group at the same time, it might actually help.
Really? Why is that?
Well, it seems like stopping and restarting everything together can sometimes prompt AWS to find a new set of hardware with enough capacity to accommodate the entire group.
Interesting. So it's like a little refresh?
Kind of, yeah.
Okay, so we've covered a lot of ground with placement groups, but there's one more concept that's worth mentioning. Placement group sharing.
Ah, yes. This is a really cool feature that lets you share the benefits of placement groups with other AWS accounts.
So I can create a placement group and let someone else use it.
Exactly. It can be within the same AWS organization or even across different accounts.
So even if we're not part of the same company, we can still collaborate on this.
You can, although there might be some limitations depending on the specific scenario.
Okay, so how does the sharing actually work?
Well, the owner of the placement group has to initiate the sharing. And once a group has been shared, it can't be reshared with someone else.
So one level is sharing.
Right. And all the regular limits on the placement group still apply, even when it's shared.
Okay, so the limits are still in place. What about if I'm using a shared placement group? Do I have any control over the instances that the other account is running in that group?
No, you don't. The sharing is really just about physical placement. It's not about giving you access to the other account's resources. You're responsible for managing your own instances, and they're responsible for managing theirs.
So it's a way to influence placement without giving up control.
Precisely.
Now, thankfully, the material you provided included a really helpful demonstration of how to work with placement groups in the AWS Management Console.
Yeah, seeing it in action definitely makes it a lot easier to grasp.
It walked through creating cluster, partition, and spread placement groups. It showed how to define the number of partitions for a partition placement group. It even showed how to assign a placement group to an instance during launch.
And it highlighted some of those important compatibility requirements. Like, remember how we talked about how not all instance types support instance store? Well, the same goes for placement group.
Yeah, like the T2 micro instance. It can't be used in a cluster placement group. And the demo also showed how to modify an instance's placement group after it's been launched. Although, as we discussed, that requires stopping and restarting the instance.
Right, and it covered removing an instance from a placement group and deleting placement groups when you're done with them.
Really helpful stuff.
Very practical.
So learners, we've really dived deep into EC2 Instance Store and placement groups. We've seen how Instance Store offers that blazing fast but temporary storage option, perfect for certain use cases, but definitely requiring careful planning. And we've explored the different strategies for placement groups, giving you the tools to optimize both the performance and resilience of your EC2 deployments.
What I find really interesting is how these concepts can actually work together. Imagine you have an application that uses a distributed cache for performance. You could potentially use Instant Store for that cache because it's so fast. But then to make sure that cache is highly available, you might deploy those caching nodes in a partition placement group.
So you get the best of both worlds.
Exactly. But of course, that introduces some new challenges, like how do you handle cache consistency across those partitions? What happens if one partition fails?
There's always a trade-off.
Always.
So we've just scratched the surface here. There's so much more to explore.
Definitely.
Dig into the AWS documentation, experiment in a non-production environment, and really wrap your head around these concepts.
And think about how you can apply them to your own specific use cases.
What are the possibilities? What are the limitations? What other AWS services can you integrate with?
Keep learning, keep experimenting, and keep those questions coming.
That's what it's all about.
Absolutely.
Until next time, learners.
Happy building.